Alright guys, now we have some more interesting problems. So now the time when we have irrational roots is when we have a square root in them. Anytime you hear the word irrational, there is some form of square root in the solution. Now, we're going to go over this problem that we have here, right? The objective equation is x squared minus 3x equals -1. Now it says express the answers as both exact roots and such, right? Now, we've already gone over how to do this stuff, so let's go over it quickly to get started. So the first thing that we're going to do is we're going to take a look at this equation. For part A, we actually need to take a moment and see what our equation looks like. So this is our basic equation, and what we're going to do is we're going to take the -1 and move it to the other side so we have something that looks like this. Then what we're going to do is we're going to go and identify A, B, and C's. Now I usually do this. You don't have to. When you understand what A, B, and C are, use them. So now, in this case, we're going to say A, B, and C are these values, and then what we're going to do is we're going to substitute in and get our B squared minus 4AC. So for one, we're calculating our b squared minus 4ac, which ends up being this. And then we end up with b squared minus 4ac being 6. Now, if you remember, always look at your sheet that we had. Our summary sheet said if the b squared minus 4ac was greater than 0, then we knew we have exactly 2 solutions. Now, the reason why I went straight into this is because if you look at this, if you look at the original equation, x squared minus 3x plus 1, there is no set of 2 numbers that multiply to 1 but add to -3. So there's no even use to even try to factor that. So this is why we start by doing the quadratic formula. Now, we're not done yet. Now that we've done that, we're going to have to go to part 2 of our solution. We're going to have to use the quadratic formula. So we start with the objective equation, x is equal to -b plus or minus what that is, and remember we called that the discriminant. Now, the discriminant is what we just calculated over here, b squared minus 4ac. So it's going to tell us that when we do this solution, we're going to have 2 solutions. So now we'll substitute directly in. So we have -3 in our brackets for b, plus or minus the square root of, well, b squared minus 4ac, we calculated over here. We chunked it. We broke a problem into 2 parts, so it makes it easy to do. So we end up with 6 underneath the square root sign. The square root of 6 is not an easy number. There is no number that square roots evenly into 6. So we just leave it. So the bottom part, we substituted 2 and 1. So now when we do this, our solution is going to be when we simplify all the brackets that are in there except for the root 6, we just leave it alone. We end up with 3 plus or minus root 6 over 2. Now, that problem breaks up. Remember, we said there's supposed to be 2 solutions, so we're going to force us to, we're going to identify those 2 solutions. And we're going to say the following, that we have x equals 3. Now, we're going to say we got plus the square root of 6, all divided by 2. Or the solution is x is equal to 3 minus the square root of 6 all over 2. Now, we call this essentially this form. We call this the exact solution or the roots of a problem. Now, once we've done that, it says, let's go and approximate the roots to the nearest hundredth. So basically, if we looked at these solutions that we have here, these don't really make any sense to us as a human being. So what we're going to do is we're going to take this and you calculate the top of the bracket for the top of the fraction first. Just calculate 3 plus root 6. Hit equals. And then divide the rest of that, divide whatever you get by 2, and you end up with, as a decimal, x is equal to 2.72 for the first one. Or x is equal to, well, 3 minus the square root of 6. Hit enter. Then divide that by 2. And you're going to get 0.28 as your solution. And there we go. We're done. And these are the solutions for our last part. Okay,